How does file compression work? So, I realized today I take file compression for granted. The ability to bundle a few files together into one, and have it come out smaller than any of them, is something I just accept as a fact, but how does it actually work? I have a limited knowledge of it that includes something to do with replacing all the duplicate entries with pointers, to shrink that way, but beyond that I'm fairly clueless. As I'm always open to new knowledge, as I imagine most of us here are, I thought I'd ask. So, super user, how does compression actually work?
Lossless compression. Lossless compression is where no data is lost. Everything that is entered can be retrieved perfectly. This works well for text or binary files where the smallest error will be noticed. File compression works by taking the file and scanning for patterns, and translating those patterns into something else which takes up less space. For example, A could be turned into ATA. Granted, that's not how it works exactly, because then you have the problem, what if ATA was in the plaintext? You would uncompress the file and it would be wrong. A good place to start is either Wikipedia or the LZW data compression algorithm. There is some simply pseudocode for this copied below. All compression uses a lookup dictionary which is used to compress and decompress the file. The bigger the dictionary, the more you can compress it, although you do run into the law of diminishing returns. It's also worth noting that compression doesn't always yield a smaller file. There are situations, with small files, or when compressing random data, that you will not get a smaller file after compression. There have been some fun challenges pertaining to the ability to compress random data. Lossy compression. The above mostly pertains to lossless compression. Other types of compression used in video-audio applications such as MP3, JPG, and H.264 are examples lossy compression. Lossy compression works by discarding data that is least likely to be noticed. In audio, this is sounds about 30,000 Hz and below 100 Hz, along with other various things. In picture, static, it removes various things and merges pixels together, along with discarding data. Lossy compression is a form of transform coding. It averages out data to reduce the overall size. For example, a block of 10 pixels in an image, all of slightly different colors may be merged together to one color and thus compressed. In video compression, often instructions will be placed to only redraw pixels that have changed since the last frame or keyframe.
Compression works by finding patterns in the data, then replacing these patterns with special smaller patterns. Decompression is the inverse: find the special patterns, and replace them with the larger patterns they represent. Knowing what patterns are probable is important. For example, patterns found in text may be quite different than those found in images. Some compression techniques are lossy, they do not guarantee the expansion will recover the input exactly. This is usually fine for analog data, such as music and images, if the loss is small enough. But data such as text must be compressed with lossless techniques. It is important to realize that it is impossible to compress, without loss, random data by even a single bit. Consider a file with n bits of binary data. There are 2 to the power of n possible files. If you compress any of these files by a single bit, so the compressed file is n1 bits in size, there are only 2n1 possible compressed representations. In other words, each possible compressed file must represent more than one possible uncompressed file. Without a unique compressed representation, the decompression algorithm cannot guarantee lossless decompression.
If you want to support the channel, please consider liking and subscribing.